Alright, my name is Samuel George, and this is part 1 of assignment 5 for Comp 533. In this part, we're going to show serialization for the binary case. The second video will show for the textual. These both should be pretty quick, just going through. I just did in 2 separate videos so I could manipulate breakpoints and things like that. The second video is going to show it working in my client and servers, or clients and server, and then the custom serialization commands is going to be the fourth video. Which also should be pretty quick. So to start out here, I'm just going to turn off tracing. You can see in my serialization factory, I've selected my binary serializer. You can see the test here is calling the serialization factory from that same class. So we have 5.factory, a serializer factory has been called here. So we're using my binary serializer, and when we run it, we see we successfully serialize and deserialize everything as we should. So I'm going to turn tracing on, and we're going to go into debug mode, and we're just going to walk through each of the steps here, showing the base classes. We're going to show the correct dispatching using breakpoints in each of the class names here. And then we're going to show all the special serialization cases and demonstrate alternative serialization for the binary serializer. Okay, so to get started, we're going to start in debug mode. We're going to do an integer. So the basic workflow is you call in the dispatching serializer, you say we want to serialize, and it makes choices based on the class type of what is being serialized. The main one that gets used is this value serializer, where it fetches the serializer based on the class, and we're going to see that's going to distribute to integer. I'm going to remove these breakpoints so that in the future we can just see them down here in the tracing. So you can see we've started to serialize. We are indeed going to call this method here, which is to get the value serializer, and we're going to go to the integer serializer. Okay, so we can see we serialized an integer. Next, we're going to deserialize, so we are indeed working with byte buffers. We're going to call deserialize. We go into integer and call deserialize, and we can see the tracing all matches that, in that we serialized and we deserialized an integer. Okay, so we're going to go through each of these quickly. This one's a short, so we see the short deserializer, short deserialize, long serialize, long deserialize, double, calling the double serializer, deserialize, float, serialize, deserialize, string, serialize, deserialize, Boolean, serialize, deserialize. Okay, and again, all the tracing down here matches. Enum, serialize. So this is simulating enum. So we showed the 7 basic types and the dispatching based on class name. We are serializing an enum now, covering this guy. Okay, and deserialize an enum. We can see the prints down here. A array. This is our first instance of an array. So serialize an array, deserialize an array. And again, you can see all the prints in here based on what is in the array. It was a string array, so we're going to call recursively the string serializer and the others. And the output here should make good sense based on what we're doing. This is an object array. So we call array list, serialize. This is our first instance of null. Since this array's last element is null, we call the null serializer. So that gets called properly, and we will deserialize the array list, and we should call in turn the null deserializer. Okay. So for the most part here, we should be almost out of breakpoints. We're going to do a vector. We call the vector serializer, vector deserializer, and a map, call the map serializer, and the deserializer. Apologies. Okay, so you can see it, we deserialized a map. Table, a serializer, table, deserialize, and set, what I called hash serializer, hash deserialize. Again, we've got the set, and now we're going to do, we already did a hash set. Okay, so we deserialized with built-in internal arrays and all of that business. For the second part, we're going to see recursion. So this in turn is going to call our reference serializer. This just serializes the number of the position in the previously serialized objects which the object occurs. So that's going to be a reference. So we reference serialize and we reference deserialize. We can see we retrieved the correct object. That's what this collection was done. Lastly, we're going to show the list in bean patterns. So we call the bean serializer for this guy. It's going to go through each of the properties and serialize them, which we'll see in the output. So we serialized all the elements of the bean, and then we are going to deserialize the bean. That's here. And you see we got the correct thing. Next, we're going to do a named BMI, which is a list pattern. Okay, so we went ahead and did the named BMI, and that translated fine. Next, we're going to serialize string history, which is an element of list. So we're going to deserialize list pattern and deserialize list pattern. Okay, and that's all the types. So the next one is just an object history, so that's just going to print and show all the objects that were getters and setters. And then lastly, we have a recursive collection with this collection. Okay, just a quick note, in the bean serializer, we did all of the, for deserialization, we did all of the properties, and then lastly, we invoked initialize serialized object in the event that that the element existed. That existed. Okay. Lastly, we're going to show serialization alternative. That is, we're going to hand it an array list, and we're going to deserialize it as a vector. So I've created a new array list, and with tracing, you can see we use the array list serializer, but then use the vector deserializer, and the object we output was indeed a vector and not an array. And so this shows alternative serialization. So we have shown serializing the base cases, null, all four of the enums, a non-tree data structure with self-references, and then alternative serialization.